For those of you who don't know me, my name is Dan Elder. I am the Linux Services Manager with Novacoast. I'm going to talk a little bit about Ceph and the enterprise. With me is...
Hey guys, we're getting started. Dan here. Hector Novacoast, sales, not very smart, but I got Dan here and he's going to take it off.
Don't let this guy fool you. So I want to keep this as interactive as possible and to encourage people to make this interactive as possible. And I apologize to those who were in here earlier from my session. I didn't have these before, but I've got shot glasses now. So ask a question, win a shot glass.
Is that a shot glass?
Yes, it is.
Yeah.
2 fewer now.
Right.
Sorry, I'm tethered. I don't know how far I can go.
Cool.
Oh, that's a good question. I don't actually know what it stands. We're going to talk about that. I've also got lots of these little screen wipies. So there you go. All right. Excellent. So with that, go ahead and start digging into slides. Again, though, the goal here is for you to be able to ask questions. I don't care if we go off on tangents or things like that. As long as you're learning what you need to learn, that is ideal because it's, this is your time. I'm here yapping at you, but if it's not worthwhile, not here to waste your time. So please ask questions, throw ideas out. This is supposed to be more of a discussion. I like these small rooms because the last time I did this was very interactive. Big rooms aren't so much, so we'll dive right into it. But again, if there's things you want to see or talk about, bring it up and get a shot glass. So going through the agenda, we're going to talk a little bit about what's the state of storage today. What do most storage environments look like? What's the industry doing? Where are things? We'll talk about what it's going to look like in the future, or at least what we think it's going to look like in the future, starting with some of the technologies available today. Obviously, Ceph's going to be a big part of that. We're going to talk about a specific customer use case. In this case, the customer was us, Novacoast. Not only are we a SUSE partner, we're actually a paying customer. And this is something we deployed internally. And we went through all the fun of being on the very cutting edge of that. We'll talk about all the things we learned in that process so that it's easier for you when you go through and do it yourselves. We're going to talk about why we chose Ceph. So there's a lot of different options out there. Why did we choose Ceph? What went right? Those are all fun things. It makes us feel good. It's nice to cover all that. But more importantly for other people is what went wrong. Because you can learn from the mistakes of others. And if you can do that, even better. And then we're talking about next steps both for us and for a lot of the customers we're helping make this migration as well. So we'll talk about things that are coming down the pike in the very near future for us. Any other topics people are interested in? Any questions, concerns at this point? Okay, very good. So to start off, where is storage today? What's the state of how our data exists? Well, it looks a lot like this. It's very siloed. It's very expensive. A lot of the traditional storage vendors, they're finally getting a little more competitive on price because they have to, but it's really expensive. And it's geared towards very high-end tier 1 storage, and a lot of times you're using that in places you don't need to. And as a result, it's even more expensive. And you face this challenge of these monolithic vendors locking you into their product lines. It doesn't really work well with anything else. And once you kind of invest in one vendor, you're really stuck there because, oh, well, if you want to add X amount of storage, you can either start over with a new vendor and invest a ton of money, or you can just pay a small amount and add on your existing investment. But once you're roped in there, it's really hard to justify making that switch to something else and paying that upfront cost. It's very tricky. So that model works well for the storage vendors. Doesn't work so well for the customers. It's very centralized. The way their architectures are built at, you've got your controller, you've got the arrays wrapped around it and everything else, but it's not really designed to be distributed. You can have separate SANs and separate locations, replications, and things like that, and all those pieces work, but it's still a very centralized model, which is not really the way the world's heading. We're heading more towards decentralized, towards being able to scale out rather than scale up. So it's a little bit challenging with that architecture. The storage vendors are slowly getting it. Some of them are coming out with what they call software-defined storage or hyperconverged type solutions, but it's still generally the old model. And storage today is proprietary largely. It's built around complex code that does certain things, but the vendor is the only one who has control over that. And that's a challenge if you want to do anything beyond what the vendor wants you to do with your storage. If I want to access it from a different way, if I want to use object storage against my traditional SAN, good luck. You can't really extend or do anything beyond what that vendor supports. If you're lucky enough that they have an API, developing against it's going to be really painful. If you find bugs or need changes or things like that, you're pretty much stuck. Open source, you don't have that problem. Everyone's working on it. The pace of development is very rapid, so it's a very different type of environment. And a lot of the storage is performance-oriented. And that's not a bad thing. You've got a lot of application workloads that really need incredibly high-performance storage. And for those types of workloads, great. These things are heavily tuned. They can tell you exactly what the IOPS are, everything like that. That's a good fit. But there's a lot of tier 2, tier 3, tier 4 storage that really doesn't necessarily need this type of model. So, quick overview of where storage exists today. Any questions about that? Is this kind of the world you're used to, for the most part? Remember, ask questions, get shot glasses. Keep this interactive.
Dan, you're doing my trick.
Excellent.
Pass around.
That wasn't quite a question, but you still get a shot glass.
No, yeah.
Between my terrible aim and these being glass, this could be a fun session. Anyone here in doctor, EMT? No? All right. I'll have Hector pass them out instead. We'll skip the lawsuit phase. OK, so looking at the future, what do we see as kind of the new model, the new paradigm? Where is it going? Well, the challenges are numerous. Anyone here have shrinking data year over year? You're retiring sands and just, no. Your data is exploding everywhere. They're finding all kinds of new use cases. Previously, all this machine-generated data and a lot of other things, even if it did exist, you weren't using it, you were just discarding it. But now they're building all kinds of analytics around it. They're wanting to log and capture even more information, or you've got video surveillance systems that they want to hold on to longer, either because it's actually useful, or there's compliance reasons, or other regulatory requirements. All these new use cases are coming out because people are learning data is really useful. Generally, not always. Sometimes you're just holding on the data because someone wanted to, but a lot of times you can gain very useful insights by looking at data historically and trending information and all those things. And so people say, yeah, let's keep, let's aggregate that data, let's hold on to it. The problem is they're not the ones that pay for the storage budget usually. And that's a little bit tricky for you because even though storage is getting cheaper, I think I've heard roughly 25% year over year, the cost is going down. The data growth is going up by 40% on average year over year. So you're still being stuck and being told to do more with less. And that's not easy. Data is great, but you still got to put it somewhere. We're also getting more into that decentralized model. You're not keeping all your storage in one location because people don't like single points of failure. They don't like having to access it remotely and have it be slow with massive latency. Your data customers, your consumers, your users aren't going to necessarily be at the same location as that data. So you need to have something more global, something distributed across different sites, different countries. Whatever your business case is, a lot of organizations are moving their data and distributing it both for DR purposes as well as just to keep the data local to the processing and the use of that data. So it's important to be able to have an architecture that can match that. Other things that are becoming more important is the way people are accessing data is expanding. You might not just be accessing it as an iSCSI share. You might not just be accessing it as an bytes. You need something that can be accessed via object storage or block storage, or maybe even just a native file system that's exported. All these different ways of being able to access your data are important because each use case is going to be different. If I've got new applications that are architected with S3 or Swift type APIs, that's great. I can do a lot of cool things with storage. If I've got stuff that needs just a straight iSCSI LUN, perfect. I need something's got to be able to do that too. There's a lot of different ways of accessing storage, and having one vendor that can do all those things is really important. You don't want to have this storage system for application X, this storage system for this application here, and all these things that don't really work well together. You're making a bad investment by having to go that route. You kind of want something that can support everything. Ideally, anyway. The need for data security is growing. A lot of people look at the types of hacks we're having today, and the model has really changed. The model used to be you would hack into someone, maybe try and blackmail them, maybe you were just trying to embarrass them, and it was not a big deal. The types of attacks today are designed to kill your business and burn it to the ground. You've seen that in some of the high-profile ones where they take all the data, they wipe everything, release everything embarrassing they can to the whole internet. You saw it in a presidential election. You've seen it happen everywhere. Keeping your data safe is very critical. And that's, no matter what storage solution you're looking at, you need something that you can really architect around to keep secure. Yes?
I might be jumping ahead, but we're federal government, so we have to go with vendors that provide X amount of, I told you this before, sorry.
No. Like I said, I want.
To go with, we gotta have hard drive replacements for 12 hours, motherboard, stuff like that, 24, 48 hours.
Mm-hmm.
But if we can still get like the HP Apollos and then go get the ARM other ones and just put them all behind us, and it treats them all the same as far as it cares.
Exactly, yeah. So let's jumping ahead a little bit to the SUSE Enterprise Storage piece. But yes, when you're talking about, so this is going to be focusing on Ceph and SUSE Enterprise Storage. It doesn't care what vendor's hardware you're going to have on the back end behind it. It doesn't care about what SLAs you have for replacements or anything else. The entire architecture is designed to be incredibly flexible. So you could in theory cobble together a 20-year-old system. It obviously wouldn't work, and plug it in, and that would be fine. The performance would be terrible and everything else. But yeah, as long as you've got hardware that's SLES certified, you're good.
We are stuck to basically proprietary because of the SLA in our purchasing, but we're not necessarily stuck to a single provider.
Yeah.
So
yeah, no.
Right now, expansion is horrible for us because we've got HP 3 bars and a PDA, so we can only buy more 3 bars and EPA.
And guess who else knows that? Your vendor, the one selling you those proprietary solutions.
They actually screwed us up very, very badly because we talked to the storage guys. We told them we need a Ceph solution, we need the drive arrays and everything. They didn't tell us anything. And of course, it went past October before we could buy stuff.
Oh. Yes, that's a whole separate level of politics that most organizations have to worry about. But yeah, that is challenging. And yeah, storage vendors, they, like everyone, they like money, but sometimes they do some mean things to get it. So yeah, this is, and I'll cover that a little bit more in the next slide.
Sorry.
No. But like I said,
You were just talking about proprietary hardware.
yes, yeah, proprietary versus soft for open, and that's well, I won't get into too far, but
Proprietary hardware, but
for now. It just has to be supported. This has to be supported. But yeah, so the need for data security is critical. You need to have a solution that can take care of that. And open source integration is critical. While a lot of applications can support iSCSI or things like that, as your workloads shift to open source solutions and pieces like that, being able to have that flexibility and that control over your applications, over your code, over all the integration is very important. That doesn't mean you're going to go modify the source yourself. You certainly can. But how many of us here have ever, modified anything open source? Yes, you keep trying for the shot glass, Peter, but you've got one. So yes, Peter has contributed to open source projects.
He's got a drinking problem.
I think he's got a drinking solution personally, but I guess it's in how you word it. But yeah, so you don't necessarily need to modify open source to get the benefits of it. The important thing is other people can, and they're probably going to run into the same types of problems and want the same types of solutions you are. And some of them, like Peter, are going to go out and fix it. They're going to scratch that itch. And with proprietary vendors, that's not something that's going to really happen. So having that whole community, having the ability to integrate everything, that's really important. So I will still get into the Ceph pieces later. Please remind me when I get to the Ceph slide. No, I want to cover it for everyone, but don't let me forget. So talking about a customer use case. Well, so we're going to talk about Novacoast because we did this ourselves, and I've got an NDA with myself, so I'm okay to talk about this. But talking about our past environment, we had 3 different legacy SANs because we're a solution provider, and depending on who our vendor friend was at that point, we got different SAN solutions from them at good prices, which is great. But now we've had 3 different ones, and they were getting older, and we needed to upgrade. And so we looked at what the options were. We also had 2 different data centers. So we learned very early on that our headquarters is in Santa Barbara. And in Santa Barbara, if there's any type of light breeze, it can knock out power for the whole city. So it's not a great place to have your data center. So we moved to 2 across the country. And our workloads are very heavily Dockerized or virtualized. The only non-Dockerized applications really we have at this point are Exchange and SAP. Anyone here do anything with Docker much? Okay. Anyone here do SAP within Docker containers? No. So some workloads just don't make sense for that. But that's kind of where our application workloads look like. We don't have anything super high performance. We're about a 200 plus employee company. We're not massive, but because we're an IT-driven organization, we have a lot of really interesting things that we do internally. So we want to be on the leading edge of a lot of these technologies because we need to eat our own dog food. If we're going to recommend it to a customer, we have to do it ourselves. So that's, it's a big push for innovation for us. We can't sit back and wait for, be on the back side of the wave. We need to be in the front because we have no credibility with customers if we're not doing it ourselves. And we need something flexible, scalable, but for us, most importantly, affordable. We're not a large environment. We shouldn't be spending that much on storage solutions because we just don't have that much. Now, in our case, and this is very abnormal, not the best fit for something like Ceph, we only had about 15 terabytes of data. Not a lot to really need a huge SAN investment. We had a lot of more capacity than that, but we were really only using 15 terabytes of data. Most Ceph deployments really make sense at the 100 terabyte and upscale, but in our case, due to kind of a few unique things about us, it made sense to do it at a lower scale. So that's our environment in a nutshell. Really wish they'd give me one of those remote clickers. So why Ceph? And this is where I will definitely make sure to answer those questions, and if I do not, throw your shot glass back at me. Well, most importantly, the proprietary solutions sucked. They were a not good fit for us. There was a lot of challenge in matching up that price to what we wanted to do, and a lot of them just didn't have that type of roadmap to match up to what we're trying to do. They're making evolutionary changes, which is good, but we really needed an entirely different paradigm for how we manage storage, how it's deployed. Everything internally for us is very, very heavily automated. So we needed systems that we could tie in and automate and integrate well with everything else. And that goes back to a lot of different things. But one of the biggest drivers was cost. SANs are expensive. We didn't necessarily need tier 1 storage, but even for tier 2, tier 3, a lot of those solutions were really expensive for what we wanted to do. I think our quotes came in somewhere around $98,000, something like that. And this was looking at 50 terabytes of storage for distributed across multiple sites with replication licenses and things like that. It was expensive. Another reason we looked at Ceph, we're very comfortable with open source solutions. We have a large development group. They work with open source. I'm the Linux practice manager for Novacoast. Obviously, we have a lot of Linux engineers, so this isn't a huge skill leap for us to make to jump into this world. Storage isn't something we traditionally do, or at least it was new to me. I don't really deal with storage, but storage on Linux, it's not that hard to make that jump and figure out. We want something that was very scalable. Even though we have a small amount now, the new business offerings like managed services, like a SOC, like these things that we're adding to our portfolio, they can grow very rapidly. So we wanted something that could grow rapidly with us without having to go back to that storage vendor and make that expensive reinvestment to add storage. We wanted something where we could go ahead and, if we start off with HP, we can add Dell later. Or if we start off with IBM, we could add X later. Whatever it is, we wanted to be able to stay flexible. And so to your point about the hardware side, you can mix and match whatever hardware you want as long as it's SLES certified. You're fully supported by SUSE. On the hardware side, meeting those SLAs, that's really going to be more of the hardware vendor. But a lot of times too, when you look at these types of SLAs, a lot of organizations, you've got SLAs and all the chargebacks and everything else all figured out in advance for your storage offerings to your internal customers. And that's great. But one of the things in storage is that all this data is going to be redundant. And redundant in a RAID array might mean you can lose one disk but no more. In a Ceph cluster, the way that it's architected is when a disk fails, the cluster knows that it's failed. Whatever data was on there is replicated in at least one other place, and it's going to go ahead and meet back its SLA for whatever you've set as the replication policy. So if you say, this data is critical, I need it in at least 3 places in the cluster, and one of those drives that it's on fails, it's going to automatically push it to some other drive somewhere. So it's not like a RAID array where if you lose one drive, you lose 2 drives, you're completely toast. As long as there's sufficient capacity somewhere in the system, it's going to be self-healing and move things around. So You obviously still want to replace failed drives quickly, but it's not that critical because if you've got 100 terabytes of capacity and you're only using 50 of it, you can lose almost half your drives in your systems and it'll still keep everything replicated the way it needs to be. Does that kind of answer your question? Okay, perfect. Yeah, so it's kind of different ways of looking at it. But we also, we really didn't want vendor lock-in. Having good vendor relationships is great, but when you're stuck with their particular platform and they decide they're going to take their storage solution off in this direction, and that's not kind of where you're going, that's really tough. You don't want to be locked into that. Or if they get acquired, and all of a sudden that whole product line goes away because now you've got to use this other vendor's, the new vendor parent company's solution. Those things are tough. Those types of acquisitions and mergers might be great for the storage companies. They're not so good for the customers who are now stuck making this leap to this new technology or doing whatever that change is that wasn't really what they wanted, but they're kind of locked in and stuck. So proprietary was not a great option for us. We've got a great relationship with SUSE. We're a SUSE partner, so that certainly works well. Made sense for us to make that investment. And another reason to choose Ceph, chance to speak at SUSECON. It's always fun. So what went right? Well, this is obviously the important part because if nothing goes right, did not make the right choice. In our case, though, a lot of things went right. So the cost, when we looked at a couple different SAN vendors, I think it came in an average around $98,000. We were able to cut that initial acquisition cost to below $50,000. That was a huge cost savings for us. But more importantly than that, the cost to add storage was dramatically lower than what the proprietary solutions offered. Yes, sir?
Sorry, just from just the perspective of size, how many storage nodes did you start off with and what sort of drives did you put in?
It's a great question. So we had 3 SANs originally. I don't know quite what they were spec'd out or looked like. But the model we went to is we've got our 2 data centers, and in each data center we've got 6 servers. It's identical for both sites. 4 of those servers in each site are our traditional storage nodes with, I think, 12 or 24 bays of drives in them. And then there's 2 kind of gateway nodes that sit in front of it and manage where the storage, how it lives.
The monitors
So I'll go a little bit more in architecture. In our case, we actually have our monitors on the OSDs, and the front end ones are our gateways. So for iSCSI, okay. Our metadata server for CFFS, those types of services. But yeah, so that's a good point. I didn't put in an architecture slide of what ours look like. I should have covered that in more depth at the end too. Out of curiosity, how many people here are using Ceph or have tried Ceph? Okay, so a few of you, perfect. So a few of you will understand what I'm talking about then when we'll go into the architecture because it's good to know. But yeah, so the storage growth costs went down dramatically. One of the interesting ways we did this is we just left drive bays open on most of these servers. We didn't even fill them up with drives. So for us to add storage was very, very cheap and affordable. Not the way your SAN vendors usually do it or your NAS vendors or things like that. But if we need more storage, we just drop in a new server. We go out to whatever vendor of the day is cheapest or meets our needs the best, and we buy a new server, we fill it with drives, plug it in, and that's it. It's really easy to add to. I'm not locked into whatever package bundle my SAN vendor wants to give me. And another reason it's so much cheaper to add storage is when you first invest in that SAN, you get a really good deal, don't you? They give you that initial starter bundle, and comes with the controller and everything else. It's a great deal. You compare it to an alternative, and you're like, wow, this is great. Why wouldn't I go with this? It's because they're really deeply discounting it. How many of you get that same discount in year 2, year 3? You want to add things? Okay.
Other replication software.
Okay. There you go.
But we don't get the initial discount.
Oh.
We get the same price each year.
I would think that being in control of jails would give them some incentive to, no?
They don't let us take them.
Do they know that, though? Because that could be a good negotiating point.
We have script that. We leave the light on for it.
Yeah, right, see?
We're not the people that actually put them in there.
Yeah.
We can only shoot you for trying to escape.
But do they necessarily know that, though? Because if you hold negotiations in a jail cell, I'm willing to bet they'll go better in your favor. But yeah. But yeah, so other good things. We didn't really have any downtime or any loss of data. Now again, we're not a large environment. This wasn't a really complex move or migration for us. But that's important because data is the most critical thing you have in a lot of cases. Without your data, there's not a lot you can do. So it's important to make sure that you've got it, something that's really going to work the way you think it is. And the pace of innovation has been fantastic. Now, the pace of innovation is always very rapid too, because again, this is open source, and open source moves very quickly. And the way you can kind of think of this is the way Linux kind of ate into the proprietary Unix world and kind of gobbled it up with commodity hardware. It did it really rapidly too. Same thing's going to be happening in the storage world, and this is kind of the tip of the iceberg type deal. But that pace of innovation, that pace of change, is incredibly rapid. So keeping up with it, it's not that hard, but this isn't going to be something where you install it and forget about it for 10 years. Upgrades come out fairly regularly, and they're fairly significant upgrades at this point, at least, because it is still early in that life cycle. So those are things to watch out for and be aware of. But there's constantly new features. For example, we're in the process now of upgrading from SES 2.1 to SES 3, and next month SES 4 is probably going to come out. So we'll be doing that upgrade again. So it's not a hard thing to do. It'll probably take us a few hours, but just something to be aware of. You obviously don't have to make that change right away, but the features and additional capabilities you get are really going to be awesome. Interaction with SUSE has been great. Obviously we're a SUSE partner. We're here at SUSECON. We are very invested in SUSE and that relationship, but they're equally as invested in us. They care very deeply about us. We have a relationship with the product management. We've been able to, when we run into problems or have questions or concerns, we can talk to the people who are writing the code. That's something that you're not going to get very often with your traditional storage vendors. There's going to be 18 layers between you and the person actually doing something. SUSE has been a great company to work with because they don't have that. You tell them what the problem is, and if they can't figure it out right away, they'll just escalate that right up, and you get to have some good conversations and learn a lot of interesting inside things.
Yeah, and just to emphasize too, our CTO and Dan have sat with the product manager, Larry Morris, right, to really roadmap what he needs, and SUSE has been very responsive and worked toward meeting those needs. So the relationship is really strong.
Yeah, you get to take a part in product direction. That's important. You get to it's not built around just what the vendor wants. They're going to listen to the customer, so that's been good. But most importantly, our end users, they don't really know anything's changed. They know we have fewer crashes and less downtime because we moved to new stuff, but that's about it. Our CFO probably knows because the check he wrote was so small compared to what he was going to have to write, so he's probably thrilled. But aside from the people who set it up and the people who wrote the check, it's business as usual. And I got to speak at SUSECON, so that clearly went right too.
Can I ask one quick question?
Absolutely, no, many quick questions.
You're talking about the costs going down and that.
Yes.
Since you've rolled it out, have you seen performance differences versus your old SAM technology?
Sure, so that's a great architecture question. So the performance is different. So the way we have to architect things was, so for example, in our architecture, we've got SSDs for the journals and the different devices, also for our metadata server, but the rest of it's just SATA. So the original SAN solution we had was also all spinning disk. So we weren't going from something high performance to begin with. If we had been going to something where we needed more high performance, that's where we would have looked at putting in a caching tier potentially, or more SSDs. We would have had to look a little bit harder. And actually, in a couple slides, I'll cover our future direction too, because that's a perfect question for that. But yeah, in terms of performance, it's been great. It's just been something we have to make sure when we first spec'd out the hardware, and this is kind of one of those big challenges. So when you're dealing with a proprietary storage vendor, they've got their small, medium, large, and it's wrapped in a nice little box with a ribbon around it, and the IOPS and everything else. And that is convenient. You don't have a lot to choose from, but you know what you're getting. With this model, you can pick any hardware you want. You have almost infinite choice to design the system the way you want, which is great because you're not stuck with whatever someone tells you want to do. You can do whatever you want, but it's challenging because you have to figure out exactly what you need then and figure out that model for what you want. So, and here's my Novacoast obligatory plug is we'll help you figure out those types of things and solve those challenges and spec it out. But that's really the hard part there is once you've got the hardware, getting the software installed and configured isn't that challenging. It's really figuring out, what hardware do I need to get the performance that I need to meet. So yeah, there's a lot of different tricks there. There is no set answer. Some of these reference platforms that SUSE is coming out with do have performance benchmarks and things like that. But in that space, it is still a little bit new. It's hard to say conclusively, I'm going to get this set of hardware and get these many IOPS for this volume and whatnot. Those numbers are a little more nebulous. So that's something where you just need a little bit of expertise. Unfortunately, I wish I could give you an easier answer than that. But yeah, that's kind of the state of things. But yeah, you get to be a little more fun. So what went wrong? Well, things always go wrong. That's life. But like you said, figuring out that hardware, we didn't do it perfectly. We did this very early in the SUSE Enterprise Storage lifecycle where there was not a lot of documentation, there's not a lot of guidelines. We worked in partnership with SUSE to kind of spec things out and do some of that stuff. But it turns out we didn't quite pick out exactly the right things we needed. This was, it happens. And some of that was because we didn't know what we needed at the time. Our workloads changed. Things happened. For example, we moved from our regular SAP environment to HANA. And all of a sudden, where we didn't care about performance, now performance mattered a lot more for loading that data set initially. So we have to now take a look and see, oh, okay, well, the storage solution that we built everything around, maybe we need to do some tweaks. Maybe we need some SSDs in a specific pool just for those types of workloads. There's some different things we're looking at there. But that's it's because our goals weren't necessarily fully defined before we implemented this. We had an idea of what we wanted to accomplish, and sometimes those use cases change over time, or sometimes we don't clearly define them. And for us, the big goal was get off our older SANs, which were old and out of support and failing. So we achieved that. But some other goals around getting everything replicated across multiple sites and things like that, that ran into a big issue because at the same time we were doing the storage migration, we're also doing data center migrations. We actually moved to 2 new data centers, and that threw a big monkey wrench into our whole storage plan. And nothing to do with the storage side of things. It's just that a lot of other stuff happened in the meantime, really pushed the timeline back on our project, threw a lot of other pieces in the works. And that happens with projects. That's part of life. You have to adapt and deal with it, but it's something to always watch out for, like those changing use cases. That's, that was a challenge when it went from, back when we first spec'd out SAN solutions, it was everything's running on VMs, and this is the type of performance we expect and the type of use cases we expect, to now everything's Dockerized. The workloads are going to look a little bit different. And oh, by the way, we're throwing HANA into the mix, or we're going to start doing some data analytics, which are very I/O intensive. So you want an architecture that's going to be flexible enough to kind of meet your future needs. And if you don't try and anticipate those in advance, sometimes you don't end up speccing things out quite right. And it happens. But this is a flexible architecture. There are things that we can do to mitigate that and meet these new needs. We're not stuck in one type of thing. There's a lot of things we can do to make that better.
For your drives, are you in the Ceph configuration that this drive is using, like enterprise, quality, SAS drives, or something different than that?
We're actually using SATA largely. So our old solution was SATA. We felt that we'd get the same performance we needed with new SATA systems. But yeah, that's one of those things that goes into speccing it out. The systems we have, unfortunately, you can't mix SATA and SAS. We also are 3.5 inch instead of 2.5 inch because there's a huge cost savings there. We went for cheap, which is good. It met exactly what we expected out to do, but then things changed over time. So that's where maybe we'll add some dedicated systems, or we can still throw SSDs into our systems. We have open drive bays, or we can throw in new ones with SAS. Hardware is always getting faster, so anytime you're adding new systems, the speed is going to improve. But another interesting architectural bit about Ceph is that, unlike a lot of storage systems, as you add nodes, the performance generally goes up. And that's kind of weird for a lot of people to kind of, wait, how? It's because as you're adding resources, it can distribute them more evenly between systems. You're adding more CPU, more memory, all these other things. So when it scales out, when we talk about scale out, it really does scale out. And the more you scale it out, the better it gets. There's more redundancy and resiliency, but you're also getting more performance because it can distribute things so much better. It's tracking where all the data lives and where the performance bottlenecks are, and can rebalance that for you. Some of that's automatic. Some of that you have to set up through the crush map yourself and tell it where data should live, depending on locations, where it should replicate. And there's other things you can do with Ceph too. So the two main ways of ensuring your data is available is through replication which means I've got 1, 2, 3, however many copies of my data spread throughout the Ceph cluster. Pretty easy to understand, and it supports everything you want to do with Ceph, so you can have some fun with that, and it's easy. But if I need 1 terabyte of usable storage, I've got to have 2 terabytes of raw storage. If I'm going to have a replication factor of 2, if I'm going to increase the replication factor to 3, meaning I've got 3 copies spread throughout the cluster, now I need 3 terabytes of raw space for my 1 terabyte of actual data. So replication is one way. The other way is through erasure coding. This is probably easiest to think of as RAID. It's more traditional where you're calculating parity and storing that, and it reduces your data requirements, or your raw data requirements. That's a good thing, but it comes at the expense of it needs more CPU and memory because you're calculating those checksums and everything else takes time. And the other issue you're going to face there is it doesn't fully support all the Ceph features and functions. So replication is normally what people go with, but you do have the option of using erasure coding.
What was your second bullet point?
Data center availability impacted implementation. So when we went to go deploy our storage solution, it happened to coincide, unknowns at the time, with our migration from 2 data centers, 2 old data centers to 2 new data centers. Different states, the whole deal. And getting the new networking set up and everything else was a much bigger mess than we anticipated. And so just sheer resource constraints and everything else, it pushed the storage migration back. Nothing to do with Ceph or SES or anything else. It was just, life. Yeah. Any other questions on this slide? Perfect. So what comes next for us? Well, this is fun. So things we want to do is we want to scale out our storage capacity because we are growing. And that's easy for us. We're able to add more drives. We have existing bays open. But we can also increase our performance. So if we need to, we can add SAS drives with SAS drives. We can add SSDs. You can add an entire cache tier if we need, which are specialized servers, which are just there to improve the performance. They basically cache a lot of the reads and writes, and you don't have to deal with the full round trips. And they do all kinds of nice things in the architecture. But for us at the time, they were overkill. Storage changes. Your needs change. So we can change too. We are going to be doing a lot more integration. So in addition to software-defined storage, we very heavily used software-defined everything, meaning software-defined networking, all the whole software-defined buzzword, everything. You might probably seen our booth with software-defined storage and blah, blah, blah. But we do software-defined networking because it saves a ton of money and it's automated. The vendor I think we work with is called Cumulus, but there's a lot of different solutions out there. SLES 12 SP2's got some interesting networking things out there. But it cut our networking costs, I think by about 60%. And again, we're all about saving money and doing more with less. Plus, we can automate it, so we can use Salt, we can use Chef, we can use Ansible, we can use whatever it wants to manage our storage environment, manage our networking environment. So everything's completely automated. When we deploy a new workload, it automatically gets the storage it needs set up. It'll automatically configure the switch port for whatever ACLs we need to allow traffic for it, because we don't even actually use firewalling. It's all done at the network layer. So there's a lot of interesting things we can do with that as we move to this model where these devices are all just computers. We're not treating it like some special storage system or some special network system. They're all computers. We can interact with them like we could anything else. They're all Linux-based, and we can script things out. So all that type of integration work is going to be really interesting for us. Gives us a lot of flexibility, a lot of control, and we get to play with some cool stuff. More upgrades, more features. So like I said, in about a month, I'm guessing, SES4 will be out. That's got a lot of additional capabilities, but one of the big ones you're going to like if you haven't tried this before, you're going to save yourself a lot of time because OpenATtic will be part of it. And that's a web front end for managing all this storage. Anyone here used Calamari? Okay, a few of you. Were you able to do everything you needed from within Calamari? Did you need to drop to the command line and do things like that?
No, but you won't be able to do everything with OpenATtic either.
No, it's true, but you'll be able to do a lot more.
More.
Yeah, so. Yeah, so I would say roughly 10% of what I needed to do within SES I was able to do through Calamari versus I expect to be able to do maybe 80% or more through OpenATtic. So it's not just a small jump, it's a huge jump in terms of functionality. So these types of new features coming out are fantastic. There's new capabilities coming out. For example, CephFS is a big one for us. Anyone here familiar with CephFS? Okay, perfect.
And they went through the roadmap. OpenEdX got a pretty nice roadmap.
Yeah, they're doing some great development on that. And Peter tells me that they used to be former SUSE guy at the lead too, so that's good.
Some of them are, and they integrated it back into systems like that.
Yeah, so those are going to be great things, and all we have to do is apply some RPM updates, and all of a sudden we've got new features, new capabilities. So it's a lot easier than replacing a hardware controller card or things like that, or going through some of those firmware upgrade processes where you're crossing your fingers and sacrificing a chicken and hope everything goes smoothly and you didn't just blow away your SAN. This is just commodity x86 hardware installing some packages. It's not hard. It's not rocket scientists, and it's something that's just coming for us. We don't have to do anything. SUSE is doing all the heavy lifting for us. We're not rolling around distribution and having to worry about any of that stuff. But so what CephFS is, so going back to the Ceph architecture, one of the things we really liked about Ceph is that you can access it through a lot of different protocols. We do a lot of in-house development, so S3 and Swift and those types of access methods are great for us because we can write applications for that. But almost every other application out there is not going to be able to use those types of protocols. It expects iSCSI or a native POSIX file system or NFS or CIFS or whatever it is. So it's really important to be able to support those, and Ceph does. And I think the only enterprise distribution that supports those is SUSE Enterprise Storage. So it was pretty easy for us to make that decision. But being able to take advantage of some of that stuff like CephFS, where I can just mount it from any one of my Linux systems, and they've all basically got a giant clustered file system now, which scales with my Ceph solution. That's really powerful stuff. Clustered file systems are kind of tricky to get right, and they've really made that easy to do and deploy and set up, as well as be massively scalable. So it's a cool thing to be able to work with. It's continuing to mature, so we'll take advantage of it and use it for things like our Docker backends. And like I said earlier, caching tier. If our performance needs increase, we do have that option. We can grow it out with caching, go through and do some fun stuff with that to make sure we're getting the performance we need. But there's other options too with the Ceph architecture. Switching drives from SATA to SAS, just adding more nodes even. We could add more of what we've already got and still get better performance. So there's a lot of different ways of doing that.
You want to remove it, you just add more and then tell them to migrate everything off of it?
Yeah, or if you've got excess capacity already, you can just start taking systems out. Just deactivate them and pull them out. But yeah, traditionally, if you're going to swap an old system, nope, it just rebalances everything for you. So if you and this comes again back to choosing what hardware you want to get. So for example, if I've got 4 massive systems with a ton of storage and I'm taking one of them offline, it's got to do a lot of data replication to make sure that it's still meeting whatever the replication factor is or everything else. Versus if I've got 12 smaller systems, but I need to take one of them offline, replication becomes a little bit easier. So you've got to kind of evaluate those trade-offs between nice density and big beefy boxes from having a larger number of nodes. So there's benefits to both ways of doing it. It's going to depend a lot on the use case, what you're trying to do, where the data is going to live, what those workloads look like, how your hardware availability is expected, what kind of SLAs you have to meet for your customers.
That's what I was thinking, because based on what you said, it sounds like, right now, if we add more capacity, we have to bring in new SAN.
Yeah.
And then we got to migrate, it's got to be bigger than what we have, and we got to
Yep.
migrate to it. Just being able to throw in stuff, okay, and then,
Just add machines.
Yep.
all of a sudden I'm upgraded and the users never do anything except for maybe some slow response.
With this, there's no forklift upgrades.
Not anymore.
Yep.
It's in place, real scalability.
In fact, when I do a demo, laptop demo, it's a tiny system, but it shows the functionality. So what I'll do is I'll create a Ceph cluster on virtual machines on a laptop, and I'll add a big USB as one of my OSDs. So boot it up, it's all stable, all the dials, all the knobs are green, and I just pull the USB key out. It goes to yellow, you see it start rebalancing the cluster. If I stick it back in, it'll start rebalancing that data back, it'll go back to its prior state. If I leave it out, it'll completely rebuild it. It's really very, very self-managing, self-healing. Self-healing. There's a lot of intelligence built into the OSD code to do that sort of thing.
Yeah, so you can drop in a new server anytime and grow your storage out. Take out an old one, retire it. It's you know, as long as you're giving enough time to replicate without having to swamp your network, you're fine. One thing to be aware of though, as you know, because hardware gets old, we eventually have to replace it and put in new hardware or add hardware, things like that, is for these storage pools, if you're mixing and matching a lot of different types of hardware, and some are fast drives and some are slow drives, your performance is going to be a little bit wonky. You're going to have to watch out for, you know, the least common denominator in terms of storage speed, because if that object lives on a slower disk, that's a problem. Now, with the crush map, which is where you map out where your data lives, you can give different priority to different OSDs and things like that. So it can has an idea of the performance itself and can tune around that a little bit. But you know, if you've got 3-year-old servers which are getting end of life, and you start putting in new servers which are twice as fast type things, you're going to want to do a little bit of tuning to make sure that it knows where the fast data lives and where those pieces should go. You know, just something to be aware of. But yeah, you could absolutely do that. It's very easy to change and make modifications to. It's all just commodity hardware, mix and match whatever vendor you want, anything else, whatever makes the most sense.
You know, like for example, one of the key features, how long does it take you guys to do it?
Well, we got all tier 1, okay, you know, the HP 3PL car, EVA, stuff like that. So, you know, we're looking between 24 hours.
Ceph usually will rebuild it every now.
We've got 320 terabytes, and it takes us 24 hours to measure most days.
That means you've got the great performance, and
Not really, not with the, it limits more of our administration and being able to create new lines, attaching the stuff to it. It's designed not to have that performance hit.
one thing I will say, I don't know if you can talk about it, one of the great things about this is because of the way the nature of SUSE Enterprise Storage, it's awesome, it's a complement to existing storage. It actually helps preserve your existing storage investments. So you can take off the archive of data and the less important data that you don't need constant access to. That's where we move that to Ceph, which is low cost. Then you can keep your transactional.
That's our plan. I mean, that is our plan. We have, they started doing testing using one of our EVAs for backup to disk. So we tested it, we showed it worked, we were backing up one system, you know, it was maybe 40 gigs.
Yep.
And all of a sudden somebody said, okay, start it. And without talking to the people who did the testing, next thing I know, they're using 320 terabytes to do backup to disk. And because of the system that they're doing it on, it's costing us like $600,000. Because it is the
Wow.
top of the line EVA tier 1 storage.
Right.
So, and then this is a bit of anger for me. And I'm sounding like a parrot. But when we went to
You don't sound angry enough.
when we went to HP storage people, we said, we need your Ceph solution hardware. They came back and said they didn't have one. They quoted us out lesser 83 cars. Apparently we're supposed to talk to the server people because they're the ones that know about it.
Yeah.
And so, you know, and plus being the government, we actually went out and, by the power of Google, found the HP Apollo. But by the time we got it to them and they were able to get us a quote back, it's past October 1st. We don't have a budget, so, you know, we can't beg for more stuff until July unless we get a budget. So I'm using lots and lots of money. I mean, and there's stuff I didn't know, like I didn't understand the whole hardware upgrade stuff of just throwing something else in and okay, you're done, remove everything off of it. Because you know, right now we're moving from the EVAs to 3 cars, so we're having to. You know,
It's a whole migration.
Everything off the EVA, replicate it over, but that's downtime. Sorry.
No. Yes. So this is actually the last slide. So this is, I think, perfect discussion stuff. But yeah, I mean, that is the important thing. That's a great point to make. Is if you need tier 1 super high performance stuff, SANs are great. That's really what they're architected for. For the tier 2, the tier 3, the tier 4, that's where this is a perfect complement. You know, in our case internally, we didn't need tier 1 storage, so we did this for everything. But you know, if you've got both, absolutely use them. Now, if you've only got one, that's unfortunate. That's expensive.
They like you even more because all the tier 1 storage people today, they're saying, well, you can have X number of SSDs, X number of this speed, and X number of this speed, and we'll monitor your data and who's doing it, and we'll move it between them as possible. You know, we don't need to do all that before.
Yeah, so things like automated cache tiering, those are really cool. And you can do that with Ceph too. That's where that cache tier comes in. And those are all nice things to kind of help you optimize where data lives. But yeah, that's not cheap from the traditional vendors.
No. And like I said, our use cases are slow, like web log access. You know, 3 months of web logs for us is 60 terabytes. And we just got a directive from Congress we have to keep over a year.
And they give you a budget along with that too, right? Yeah, yeah, they just threw money at you? Yeah.
Yeah, we had to we actually had a SAN crash, so we shrunk our data 180 terabyte in like 10 minutes.
That's one way to do it.
But it was mainly our indexes for email archive, and we spent 8 months re-archiving.
Oh.
580 billion email messages.
Yeah.
We have to keep them for 7 years for every employee, and exec staff, we got to keep it permanent until we can archive it off and send it over to national archives.
That is brutal.
So I just want to ask you a question, if you don't mind, because I'm not quite understanding. I was in the session the other day when you mentioned about your SLAs and that. But to me, this technology is suiting you more than a traditional SAN with your SLAs that you have.
We see our SLAs are based on the hardware. I'm directed by the Department of Justice anytime I put out a request or a request for contract or anything like that, that I have to include, if I have a hard drive failure, the vendor replaces it within 12 hours.
So the vendor replaces.
Yeah, or whoever I buy it from.
Okay.
You know,
Sure.
if you're a reseller and I buy it from you, it's up to you to meet that 12 hours, or you can't bid on the contract.
But I mean, these are a lot easier to replace than.
Yeah, that's what.
Yeah.
We found, like, when we set this up, we showed how it worked, everybody wanted it.
Yeah.
Then we went looking for hardware to meet our requirements,
And that's what you
and we couldn't find it.
Because most,
And, you know, we Googled it, we found companies everywhere that make these Ceph servers, you know. We'll send you, you know, they would even machine in our own envelope into some of the boxes for us. I'm not making this up,
Like that's what you
but
do,
they
yeah.
couldn't offer the support that's required by us.
and that's why it's nice to be able to use whatever vendor you want. I mean, obviously you've got requirements around vendors, but any vendor's hardware is going to work with this solution. And a lot of them have, like,
If it wasn't for the hardware SLAs that we have.
well, they can meet those though. That's like, you know, with HP, we've spec'd out solutions for our SLA. Yeah, so that's the problem. You're talking to the storage team instead of the server team, and that's.
We had it, the solution sold to management. We just could not find the hardware to where I could put a contract out on
Yeah, that is unfortunate because those SLAs don't come cheap when you want 4-hour on-site service, but it is an offering.
it. And then you have management that doesn't listen to you, and they go out and buy like a NAS device.
We're going to do Drobo boxes everywhere for all of our.
This was Spectrologic birthday or something like that.
Okay.
Something we had never heard of before. But we use Spectrologic for our jukebox, our tape
Okay.
jukebox.
Yeah, I mean, there's you know, there's not a one-size-fits-all solution. There's different solutions for different problems, but when you try and use the same solution for everything, it can get expensive.
We even had the replication set up to say, look, we don't even have to, you know, this is our disaster recovery. You know, if this goes down here, we've still got all of our data down in a place down in Greensburg, Texas.
Mm-hmm.
And, you know, it's completely hands-off. And it's cheap because, you know, with the level tier 1 with those SANs, you got to pay for replication.
It's really expensive.
And it gets expensive, and they limit the amount you can do.
Yeah. Yeah, Ceph does all that natively. It's all just built in and part of the solution, which is one of the reasons we're using it because we're across the country. Now, one of the things we may be doing actually is we're probably going to break our cluster because our WAN isn't quite big enough to keep up with replication and just have 2 separate ones and do something else for replication. But if you've got the bandwidth for it, you can replicate and do anything you want. So,
I mean, where we plan on putting it, we got representation. We have some institutions with like a T1 still.
Yeah, 110%
110.
well, you get your money's worth out of it at least.
Never mind. It goes with the whole department requiring the SLA. They also require we put like the active defense plan on it. Who does it? That we have a client to monitor security and
Okay.
it shut down the bandwidth at multiple institutions. And when we went to the department telling them we're going to do it, they're like, no, it's got to be on there.
Here's a term, it's called production prohibited security.
Yeah, that could be a challenge.
Yeah, Air Limits wasn't the software or technical expertise or anything like that. It was finding the hardware that meets our requirements.
Yeah, I mean, politics and stuff in it, but if you want to, pitch something like this, the thing to realize is when you're looking at Google and Facebook and all these massive enterprises, they're all using architectures like this. This is the architecture of scalability. You look at the Large Hadron Collider, it's CERN, generates petabytes of data. This is the architecture they use for that. So if you want to use the enterprise-wide, most scalable solution, this is what you're looking at, which is fun because you can use junk hardware, you can use whatever commodity hardware you want, but because you're scaling out, it can work around problems. It'll work around and self-heal and solve all those issues, whereas the monolithic model of scaling up requires very exacting, expensive proprietary hardware that's very narrow fault tolerance and things like that, which isn't a bad model for some use cases, but you can save a lot of money by using less resilient hardware, but just scaling it out.
I mean, like our medical stuff, we have imaging, everything stored in it. That needs the tier 1 SSDs, everything we got it on. Because if we have a doctor cutting somebody open and he needs a different x-ray, he can't wait for it to down.
Yeah, nope, that's important.
They wouldn't be there if they found
Yeah, so those.
all
All this kind of concept, if you do infrastructure for everyone else.
It's exactly the model. We're just all catching up.
And the idea of like hardware being, knowing things are going to break. At Google in the past, they only attach hard drives to developer scripts. They don't screw them in, they just attach them to developer scripts. Because they know in a given farm of servers, or say there's 50,000 servers, and they've got multiple disks, they know count on a certain failure rate. Every day there's going to be certain ones that die. And a colleague of mine runs the Amazon data center in Luxembourg. There's one guy that works for one of the vendors, and he's called the disk monkey. All he does is walk around the data center and replace broken drives. He takes a car to drives around every day and fixes broken drives.
Good job, security, right?
Poor guy.
Probably be made well.
Well, he's going
Business
deaf.
going-
He's probably going deaf. If anything along the noise. Yep. Where's his guy?
Bit. Okay. Yeah, so some of the other use cases we're looking at with customers, things that are proposing working with them is things like surveillance video storage. This is huge. Everyone who's collecting surveillance storage feeds, they need somewhere to store it, and it's explosive amounts of data. Think about 24-hour video feeds and recording them from multiple cameras. Takes a lot of storage. Perfect use case for this. Unstructured file data, things like your iSCSI file shares, that type of stuff. Very good use case. Medical imaging, like you were saying, those files get large, and some of them need to be very high performance, but a lot of them are just being archived so that a doctor can review later on, how things have changed over time, stuff like that, or whether that was an injury sustained or treated in prison or whatever it is. And VM snapshots. So we see this a lot. So VMware environments, all these types of virtualized environments, a lot of those workloads require very high performance, and that's great. But when you're doing snapshotting or DR sites or things like that, you don't need that level of performance. You can attach an iSCSI LUN to VMware, sitting in a Ceph cluster, have all that tier 2, tier 3, tier 4 usage go there, and you're really saving a lot of money. You don't have to keep scaling up your tier 1 storage. You can put the high performance stuff where it needs to be. put everything else there on Ceph. And reusing existing hardware. I've had a few customers who have actually been able to do this because, for example, school districts are a big one I've worked with where they get bond money or whatever grant money to deploy a bunch of systems, and they do, and they don't end up using them. And so all of a sudden they want to put in some centralized storage or something in sites because then they got fiber bandwidth, and that's perfect because they've got these big storage servers sitting around not doing anything. We can basically build them a Ceph cluster for just the cost of very minimal licensing. So you don't generally want to reuse older hardware for performance reasons, but if you've got something decent around, and it can make a lot of sense. But so there's a lot of different use cases out there. Anyone who's got an interesting use case that they're looking at for Ceph or want to bounce an idea around. So you've all got great use cases. You're good to go with Ceph then, all right? I like that. That's perfect.
Well, we've already sold it.
Yeah. So we've got those mapped out. But yeah, I mean, it's a matter of looking at what you're trying to do, making sure it's going to be a good fit, because not every use case, not every workload is going to be. But for the majority of your data growth out there, it's not tier one. It's these other tiers where you don't need to be blazing fast. You need the data to be available. It makes a lot of sense to replace tape with this when you look at cost, because it often doesn't cost much more to go with spinning disks, which give you real-time access, versus these tape archives and the automatic tape loaders and those types of things. So, at the cost of commodity hardware with spinning disks, it's not a lot of money to do a lot of storage. So those are some of the things that we look at. But I think with that, I am out of time.
Braylon, last thing, can you just kind of tell us a little bit about the services that we provide and work with at SUSE?
That is a great plug by someone who totally does not work with Novacoast. But yes, I mean, that's one of the reasons we're here. We're a solutions provider. We work with SUSE. We want to come in and help you spec out, make these types of solutions work. We do everything SUSE, obviously. But the big challenge in a lot of these types of projects is figuring out that hardware match, figuring out what you need to meet your workload requirements and your application requirements and everything else. Getting it set up isn't that hard, but getting that initial piece right is really critical, because software you can always change later, but the hardware, not so much. So it's getting it all set up and integrated and working correctly so that you get that successful win, and
So like for you guys, for Dan and Jim, and when you find a storage opportunity, it goes to, and the services to get it started up, it goes to Jeff. What's Jeff, right? And
Loomis.
Jeff then sources
Yep.
Jeff Loomis, who works with us, brings in Dan, and it makes no difference for the customer, and it makes no difference for for your quotas and our quotas and everything. So everyone wins, and we just keep learning. And we're the ones that end up doing the dirty work with along with the system.
But you're only US based, huh?
no, we're yes. We don't have so our closest. Yeah, Africa's big. Yes. So when we say global,
Just that small little bit in the south.
yes. So we have offices in Canada, Mexico, and England. So we'll travel everywhere. It's just that a lot of times you want someone local because the travel costs get a little expensive. So we haven't gotten there yet, but we certainly would love to. No, I've gotten a couple of requests for that, and unfortunately we haven't grown that far yet. But we do travel everywhere.
It's part of the world domination plan.
Exactly. Yeah. Give us a little while. But with that, thank you. Thank you for your time. If you'd like a screen wiper or shot glass, come by.